Assalamu alaikum dear students. We are discussing exercise 4.1, that is to prove the given statements through mathematical induction. Now here question number 2 of this is we have to prove that sum of the first n cubes, that is 1 cube plus 2 cube plus 3 cube plus so on to n cube, is n into n plus 1 upon 2 whole square. Now we will use here the mathematical induction because the given statement, that is sum of first n cubes, contains n. Now let p of n be the given statement, that is 1 cube plus 2 cube plus so on to n cube. Now we have to prove that p of n is n into n plus 1 upon 2 whole square. Now we will use induction here. Now for n equals to 1, p of 1 is simply 1 cube, that is 1. Now RHS of this, that is n into n plus 1 upon 2, is when we put n equals to 1 is 1 into 1 plus 1 upon 2 whole square, that is simply 1 into 2 upon 2 whole square, which is simply 1. So this means that LHS is RHS, hence this statement p of n is true for n equals to 1. Now let us assume that this statement p of n is true for n equals to k. This means that p of k, which is sum of the first k cubes, it is 1 cube, 2 cube up to k cube, is simply k into k plus 1 upon 2 whole square. Now we shall prove here this result for n equals to k plus 1. Now what is p of k? P of k is simply the sum of the first k plus 1 numbers, that is 1 cube, 2 cube plus k plus 1 cube, because the successor of this k is k plus 1, and we are finding here the sum of the first k plus 1 cubes. That is why this p of k is 1 cube, 2 cube k cube up to k plus 1 whole cube. Now by assumption that sum of the first k cubes, that is this portion, is k into k plus 1 upon 2 whole square, that is this, and k plus 1 whole cube. Now here k plus 1 is common. Taking k plus 1 whole square common, it is simply k square upon 4 plus k plus 1. That is k plus 1 whole square by cross multiplication. In this, it is simply k square plus 4k plus 4 upon 4. Now by splitting the middle term, here it is quadratic equation. It is k square 2k plus 4, which is simply k plus 2 whole square. K plus 2 whole square. Now here we have k plus 1 whole square, k plus 2 whole square upon 4, which can be written as 2 square. So this means that this statement is simply k plus 1 into k plus 2, which can be written as k plus 1 upon 2 whole square. So this means that this result is of the form of n into n plus 1 upon 2 whole square, because here we have k plus 1, so it is k for n, and n plus 1 means k plus 1 by 2 whole square. So this means that this p of n is also true for n equals to k plus 1. Hence by induction, or the principle of mathematical induction, sum of the first n cubes, that is 1 cube plus 2 cube so on to n cube, is n into n plus 1 upon 2 whole square. Now question number 3 of this is prove that for all n 1 plus 1 upon 1 plus 2 plus 1 upon 1 plus 2 plus 3 up to 1 upon 1 plus 2 up to n is 2n divided by, or 2n upon n plus 1. Let p of n is given statement, that is p of n is 1 plus 1 upon 1 plus 2 plus so on to 1 upon 1 plus 2 plus so on to n. Now here we will use induction because this statement contains n. So we firstly prove this for n equals to 1, which implies that p of 1 is simply first, it is 1. And RHS of the given statement, that we have to prove p of n is 2n upon n plus 1. Now LHS, when n is 1, LHS is simply 1, while as RHS is simply by putting here n equals to 1, that is 2 into 1 upon 1 plus 1, which is simply 1. So this means that LHS is equals to RHS, hence the given statement is true for n equals to 1. Now let's assume that this statement is true for n equals to k. This means that P of k is 1 plus 1 upon 2 plus so on to 1 upon 2 plus so on to k is 2k upon k plus 1. Now we shall prove this for k plus 1. Now P of k plus 1 becomes 1 plus 1 upon 2 plus so on to 1 plus 2 plus so on to k plus 1 plus 2 plus so on to k plus 1. Because here up to n it is 1 plus 2 plus up to n. So for k plus 1, here we should have this k plus 1. Now here this, by assumption, this portion up to k, its sum is 2k upon k plus 1. Now here we have sum of first k natural numbers, k plus 1 natural numbers. You know that the sum of the first n numbers is n into n plus 1 upon 2, while as sum of the first n plus 1 numbers is n plus 1 into n plus 1 plus 1, that is n plus 2 upon 2. Here we have k plus 1 numbers, so the sum is k plus 1 plus 1 upon 2. Or it is 2k upon k plus 1 plus 2 upon k plus 1 k plus 2. Now here taking common terms common out from this, or it is simply 2 is common, k plus 1 in the denominator is common, so we are left with k plus k upon k plus 2, that is simply after multiplication or cross multiplication k square plus 2k plus 1 upon k plus 2. Now k square plus 2 plus 1 is simply k plus 1 whole square. Now this square and this term will cancel, so we get 2k plus 1 upon k plus 2, which can be written as 2 into k plus 1. Now k plus 1 plus 1. Now this is of the form of 2n upon n plus 1, because here n is k plus 1, that is this, and k plus 1 plus 1. So this means that hence for all n, above statement is true, or we can simply say that 1 plus 1 upon 1 plus 2 up to 1 upon 1 plus 2 plus n is simply 2n upon n plus 1. Now the fourth one is we have to prove for all n that 1 into 2 into 3 plus 2 into 3 into 4 plus so on to n into n plus 1 into n plus 2 is n into n plus 1, n plus 2, n plus 3 upon 4. Now clearly this statement contains n, so we will use here principle of mathematical induction and let P of n is 1 into 2 into 3 plus so on to n into n plus 1, n plus 2, n plus 3. Now for n equals to 1, now put P of 1 in this, we simply get 1, 2, 3 because this is the first term, while as RHS putting n equals to 1 we get 6. So this means that the given statement is true for n equals to 1. Now let's assume that P of n is true for all n. So let's assume that P of this n is true for n equals to k. So this means that P of k is 1 into 2 into 3 plus so on to k into k plus 1, k plus 2, k plus, which is simply k into k plus 1, k plus 2, k plus 3 upon 4. Now we shall here prove this for n equals to k plus 1. Now P of k plus 1 becomes this. Now the last term of this P of k plus 1 is here k plus 1 into k plus 2 into k plus 3. But by assumption this statement, it is simply k into k plus 1, k plus 2, k plus 3 upon 4. And last term is k plus 1 into k plus 2 into k plus 3. Now taking k plus 1, k plus 2, k plus 3 common, it is simply k upon 4 plus 1, or k plus 4 in the bracket k plus 4 upon 4. Now here k plus 1 is the last term, that is here k plus 1. Now this k plus 2 can be written as k plus 1 plus 1, 3 can be written as k plus 1 plus 2, and 4 can be written as k plus 1 plus 3 upon 4. So which is same as this n into n plus 1, n plus 2, n plus 3 upon 4. Hence this statement is true for each and every n. So this means that P of n is true and P of n is n into n plus 1, n plus 2, n plus 3 upon 4. So thank you.